Hey everybody, Dave Igo here. I wanted to do a quick video, a couple more tips and tricks for tube laser in Solidworks 2010. I wanted to do a quick video. This is a bumper. You can find a picture of the actual bumper on my portfolio page. It's an ATV bumper. Incidentally, you're looking at this is the most successful power sports category product launch for the 2009 catalog model year for the largest power sports distributor, Parts Unlimited, in America. So I'm pretty proud of that. Anyway, you can see more of this over at my portfolio page, but I wanted to show you when you're modeling for tube laser, okay, because we got a tube laser now. We can do fancy stuff, right? We can do all kind of crazy stuff. Well, here's something that you run across when you do that. This particular tube is the tube we're going to be talking about. And so I've got it open here. Now, obviously with the tube laser, what are the advantages? Well, we can put holes in and, and we can put copes in. So we can put all of the copes in this tube in the ends here, all two of them. The copes in the ends as well as drain features in the tube laser before we bend it. Now, that creates some interesting challenges. That turns this part and really this entire bumper. Another couple of tube laser features is the mounting points here, where we're putting a tube through a tube, and that winds up being really handy. But this is just an ATV bumper, right? It's not a mechanical heart. It's not an artificial leg. It's not a bionic arm. It's just an ATV bumper. However, because we've chosen to use the tube laser and put these copes in before we bend this pipe, we've created a fairly complex tube weldment here, okay? It's a simple part. It's just a bumper, and it doesn't need ultra precision QC to be a bumper and to be a good bumper. But it does need that kind of precision now that we've involved our high-tech processes like the tube laser, okay? Because now not only do we need to hold 2 rotations during bending, but we need to hold 2 cope rotations to the bend, okay? So it becomes a significant issue and something that needs to be played around with. Now, if you're bending this on a manual bender, I'm going to give you a little trick here, and I think I'm going to do a video about it. But if you're doing this on a manual bender, if you've got a roll bar bender and you want to do a bunch of roll bar kits and you're going to have somebody do your tube laser work, it'll take a little playing around, but usually on a mechanical or a manual bender, a race car bender, let's call it, there's a pinch bolt. You'll have your radius die sits in here and a U-clamp probably, or a U-strap that goes over this straight, and then there's a pinch bolt right here, okay? So all you need to do, you know what, I'm going to do a video about it. So check out my other video, because that's important. It's going to take our high-tech laser and put it down at the grassroots level where everybody can use it. So I'm going to do a video about it. I'll probably do that in a couple days. Check it out. Anyway, when you're cutting this in the tube laser, what do you need to do to this tube? Well, first you need to flatten it, okay? And by that I mean you need to develop a flat pattern, just like you would with a piece of sheet metal. Well, Solidworks doesn't really give you a way to do that. I suspect that they will for Solidworks 2011 or 2012, but there's 5 or 6 certified, quote-unquote, certified gold Solidworks partners that make a plug-in that will do that, and they're very expensive. I just refuse to believe that it couldn't be done. So once again, I needed to develop one of my renegade cheats, right? And it works just fine. So I'm going to share it with you guys, and it goes something like this. So this is our tube, okay? Let me just show some sketches here. So, this is our line, and it's derived from a structural member and brought into a new part. But there's a couple of numbers we need to know. Right there. This one, I want to measure that arc length, okay? So 1.825. We're going to call it 1.825, okay? We're going to need to know that. Now we're going to go Insert, Features, Delete Body, and get rid of it, okay? Now, normally I would write these down, but I'm just going to show you the one end here, just so you see how we do it. And I've already forgotten that number. Let's look again. 1/825, inch 825. So that's the number we need to remember. Inch 825. I'll tell you what. I'm gonna just great, so I don't forget. So there's our inch 825. Now we go Insert, Features, Move Copy. Okay, so we're going to move this body, and if you guys have never played around with this, all you need to, it works just like the mate functions. And so we're going to move this body, go down here to mate settings, we're going to mate this face to this face at our, I think it was inch 825, and do that, and go Insert, Features, Move Copy. Whoops. We're going to move this one, go to our mate settings, click that face, and that face. Voila! Now we go from there, and we come back into here, and go Sketch, Convert, and convert the ID, and go Extrude, Merge, up to Next. And there's your flat tube. Okay, now you do need to, I don't want to say you do need to, you should check your angle of rotation versus your bend after you do this. Now, I will say this. I have never, ever done this, and I've done this with a lot of pipe. I've never had that rotate. It always works. Okay, so it's like Solidworks was thinking about it, and they just didn't get to it. Check it, but it typically it works. Okay, now something I need to tell you: we took this arc length at inch 825. You're going to need to develop a scaling factor for that arc based on the degree of bend, and that's going to come from your own numbers. If you're running a quality tube bending program, you're going to know exactly what you're losing in every bend anyway, and your setup's going to be repeatable, and you're going to take that inch 825 and multiply it by 93%. Or whatever that number is. I guess if you have any problems, it's pretty simple math, guys. If you have any problems with it, shoot me an email. Go over to my website, daveigo.com, and you can send me an email, and I'll explain it more. Maybe I'll write an article about it. I don't think it warrants a video, so I'm not going to do one. If you're just bending roll cages, and you're using a manual bender where you don't have a ram pressure and you don't have a boost pressure or any of those things to consider, then what I would recommend doing is taking a piece of pipe and actually take like 4 pieces of pipe, because use a different one for each one, and simply go 22.5, 45, 67.5, 90, and just measure them all and see what you lost. It's pretty easy to do. So to automate this process, some of you are probably familiar with or know what a Solidworks macro is. A macro is it's a small program that you can write that will do repeated tasks for you. So I'm in the process of writing a macro to do this that I'm going to give away. It's actually functioning and it's working now, but it's still in beta, so I'm not going to give it away quite yet, but we're not far from it. Keep checking back to my website, and when it's ready, I'm just going to give it to you guys. It'll really, I think, help everybody out. It's helping me out already. But anyway, so that's our quick video on how to flatten a tube in Solidworks. And go to my website, daveigo.com, and check out all of my tips and tricks. And you know, this is the 3rd video I put on YouTube. I'm going to ask you guys, if you found this information useful, interesting, or you watched the whole video, please give me a thumbs up and leave me a positive, or leave me any comment. If it's a bad comment, leave me a bad comment. I want to hear those too. So thanks again, guys, and we'll see you in the next video.